The values in the fourth row of Pascal's triangle are shown in the following table. 1, 4, 6, 4, and 1. Write down the values in the fifth row of Pascal's triangle. Okay, so Pascal's triangle, we start with a triangle of ones, and this would be considered row 1. Then we always start the row with 1 and end it with 1, but the numbers in the middle are going to be the sum of the numbers right above it. So 1 plus 1, 2, and with 1. 1, 1 plus 2, 3, 2 plus 1, 3, and with 1. 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and with 1. This is the row number 4, which is the numbers that we got in the exercise. So row number 5 would be 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and with 1. So this would be row number 5. Hence or otherwise, find the term in x to the power 5 in the expansion 2x plus 3 to the power 5. Okay, let's understand what happens with an expansion. So if I do a plus b to the power of 3, what do I get? Well, I would get a to the third plus 3a squared b plus 3ab squared plus b to the third. Notice, first of all, that this row here, the coefficients, is going to be the same. The coefficients are going to be the same as the coefficients for the third row. So I can see 1, 3, 3, and 1. Also, the first term starts at the maximum exponent, a to the third, and it goes to a to the first, and it goes all the way to 0, the exponent. Whereas the second term starts at 0, this is 0, and then it goes all the way to 3. So understanding this, we can see that if I had to do the whole expansion 2x plus 3 to the power of 5, we could do, well, the coefficients 1, 5, 10, 10, 5, and 1, and I could go 2x all the way from 5 to 0, while 3 goes all the way from 0 to 5. But he's not asking for that, right? So he wants to know what he wants is the term in x to the power 5. So if I want the term in x to the power 5, then I would have to see for what value will 2x be raised to the power 5, because this is the only, out of these two terms, this is the only one that has x. So I don't have to worry about multiplying the x's and whatnot. So in this case here, this expansion is going to be equal to what? It's going to be 1, 5, 10, 10, 5, and 1. And the terms are going to be what? 2x to the 5th, 2x to the 4th, this is a 4, 2x to the 3rd, this is a 3, 2x to the 2nd, 2x to the 1st, and 2x to the 0. While the second term would be what? 3 to the 0, 3 to the 1st, 3 to the 2, 3 to the 3rd, 3 to the 3rd, sorry. 3 to the 3rd, 3 to the 4th, and 3 to the 5th. But he's only asking for the fifth term, for the term that has x to the power 5. So in this case here, if we look over here, I don't have to do all of this, right? I can see that the only term that's going to have an x to the power 5 is going to be this one. So that's going to be what? 2x everything to the 5th times the 1 from Pascal's triangle times 3 to the 0, which would give me what? 1 times 2 to the 5th, x to the 5th, times 3 to the 0 is just 1 again. So this is going to be 1 times 1, 2 to the 5th is 32. So it's going to be 32x to the power of 5.